Debugging with Docker has become easier. Docker now provides advanced build debugging directly inside Visual Studio Code through the Docker DX extension. In this video, I'll use VS Code to show you how to debug Docker builds step by step, setting up breakpoints in a Docker file, inspecting variables, and the file system during the build, and more to see why Docker continues to be the default trusted container platform for modern development workflows. Let's take a look. To get started, the first thing that we'll want to do is to install the Docker DX extension, which you could find in the extension marketplace from VS Code. And once you type in Docker, you should see that option come up here and install it. And once you do, you'll see the key features it provides. And the most relevant one for us is the second bullet point, Docker file debugging features that allows you to debug and step through a Docker file build with BuildX. Next, you'll want to make sure that you have the latest version of Docker Desktop. So on the bottom right-hand corner, you should see an option that you can click that says Update is available. And when you click it, you can just download an update, then install and restart. And then we'll want to run Docker BuildX to check the version so that we can verify that BuildX is at least version 0.29, which it is. Our next step is to create a launch.json file. And if you don't have one, when you go to the activity bar and click Run and Debug, you'll get an option to create one right over here. And when you click it, you can simply choose Docker build, and one will be generated right on the fly. And after I hit escape, I can see the configuration settings that I want. If you already had a launch.json file and you need to access it, just click on this cog icon right over here to add your necessary configurations. Now I'm ready to open up my Docker file, and I will go ahead to my project that I have here and open this up. And from here, like any other project, we can add a breakpoint. And I'll go ahead and add one right over here. At this point, we are ready to start a debugging process. Now, to launch the debugger from the activity bar, you can either go to the Run and Debug icon and click this play button, or hit F5. And once you do, we are off to the races with options for variables that we can monitor as we begin stepping through. And this is great because when a build is in a suspended state, at certain points as we step through, we can see our variables. Like right now on line 13, if I go under exec, I can see the path for my working directory, which matches line 7. And for more environment variables, such as the path and Python version, I can see them here. But in addition to inspecting variables, you can also look at the structure of the file system via the File Explorer here. So for example, by clicking this drop down here, I could see several folders. And if I navigated to ATC, I can see subfolders and files under here. And for text files, such as this one here, adduser.conf, just by hovering over the data field, you can peek into the content that's inside it, which is definitely great when debugging. But let's continue stepping through. We're currently on line 13. As we move to line 15 and 16, I'll try to continue, but right over here, I get an exception. And we could see that reflected under the call stack. And here I notice what is wrong, which is a typo. In compile all, there should be 2 L's. So I can make sure that that is saved, which I know that it is since I have autosave set in VS Code. And when I restart my debugging process, I can continue stepping through, and this time I don't get an exception. And I can continue to complete the process. Another thing I'd like to show is how the terminal view can open with a shell that is attached to the image that is being built. So for example, let's go ahead and start the debugging process again. And I will bring up the terminal by hitting Control-Tick as a shortcut. And I'll select a debug console. And now at the bottom here, there's an input field where I can type in exec, and this now opens a shell into the Docker image and can now be accessed and inspected via the terminal as we step through. This is a game changer because you can now easily open the image of the Docker file at any given step and inspect its contents and run commands for testing. Previously, we would have to comment everything after the buggy line, build a Docker image. All of that now is condensed into adding a breakpoint in your editor and just starting a debug session. And one final thing that I'd like to mention is that the BuildX debugger is built on an open standard, as it implements the debug adapter protocol, which means that you could debug Dockerfile builds with any editor that supports this protocol. And for those who use Neovim, the hyper-extensible Vim-based text editor, we do have this plugin that's specifically designed for Neovim. And for JetBrains users, we have verified that it integrates with the LSP4IJ plugin. This video was inspired by this blog here by Remy Suwin, so definitely go ahead and check it out. So that's how Docker debugging works using the Docker DX extension in VS Code. This debugging experience reinforces Docker's role as the widely adopted default container solution with tooling designed to improve the developer productivity from local builds all the way through production workflows. Thanks for watching, and make sure to watch this video here too.